Hello everyone. So today in this channel we are discussing about the Quicksort algorithm. Okay, so let's get started. So Quicksort algorithm basically it's a divide and conquer technique, and what we are doing is we are taking one of the element as a pivot element. Okay, so pivot is just nothing but a variable. Okay, so don't think that it's a element. I mean that has a different meaning, and that has maybe it's an algorithm something like that. Don't take it much complex into your mind. Okay, so it's a reference, it's a variable reference that we are taking. Okay, so take any of the pivot element, pick any random element, or pick any pick first element, pick last element, pick middle element, any of the element you can take as a pivot. Okay, but make sure the pivot whatever you are taking, the left side elements should be smaller and the right side elements should be greater. Okay, so that's how the rule that we need to get in your mind when you are applying any quicksort algorithm. Okay, so when you are writing your when you are facing an interview or when you are writing an exam, make sure this particular rule should get in your mind, like pivot elements left side should be smaller and the right side elements should be larger. Just applying a common sense, I have a sorted array. Okay, 1 2 3 4 5, I have a sorted array. Let's say I have taken pivot as 3. Okay, pivot means, again I'm saying, it's a variable. Okay, if I choose pivot as 3, if you observe here, the left side elements are smaller, 1 2, which are smaller than 3, and the right side elements 4 5, which are larger than pivot. Not only 3, just pick any let's say if you pick pivot as 2, then the left side elements will be smaller and the right side elements like 3 4 5 will be larger than 2, which is pivot. So that's how you are arranging the elements, by taking the reference as pivot and applying the rule left side elements should be smaller and the right side elements should be larger in such a way that will get arranged in the sorted order with ascending order. Okay, so for that this rule should be applied. For example, if you are arranging in the descending order like 5 4 3 2 1, and if again you choose pivot elements, then this rule will not apply. This then you guess what will happen. See, then the pivot element left side should be larger and the right side should be smaller, right? Just practice this all in your hands on. Okay, so okay, this is in the case of ascending order. What will happen in the descending order? Just you also tabulate it. Okay, 5 4 3 2 1. Take any of the pivot element, don't pick what I have chosen. Take the last element or take the first element. Make sure the left side elements should be larger for the descending order and the right side should be smaller. Okay, simple rule that we need to concentrate on this only. Okay, that is left side elements are lesser than pivot and the right side elements are greater than pivot. Okay, fine. Okay, divide and conquer. What will happen, how we divide in and how we conquer it, you will get to know at the end of this session, but yeah, just for now bear me. Okay, fine. I have an unsorted array. So without any delay, we'll get into the algorithm steps, like how we can do, because quicksort nothing much to describe. Like I don't want to explain with definitions what will happen. I mean, this session is about how we'll do the algorithm. Okay, easily I'm just explaining you with parallel. I'm writing the pseudocode over this here, so that I also request you to do the hands-on parallelly with me, so that that will be get memorized in your brain. Okay, so let's get into the algorithm. So I have an unsorted array 3 2 1 4 7 6 5. Okay, so in this unsorted array, I will be choosing the first element as a pivot, as in my reference. Okay, you can pick any of the random element. Guess what? Okay, what you can do is you can exercise it. You can exercise it by taking 4 as a pivot element or 7 as a pivot element, and try to do the algorithm steps on your own, just like how I will do, and then write your code, so then you will be get memorized in your brain. Okay, fine. So I have taken the pivot element as 3. Okay, so I will be initializing I and j here. So what I'm doing is I am pointing I at lowest index and I am pointing j at highest index. Why you are doing? If the question comes, the answer is, so what I am doing is, if you remember the earlier rule what I have said to you, the pivot elements left side should be smaller and the right side should be greater, right? So what I am doing is, I am taking I as a reference of I for the left side elements and j as a reference of and j as a reference for right side elements. That means what I will do, I'll just give a brief overview why I have taken I and j, so that you will be you will feel little easier for the next algorithm steps. So what I am doing is, I will be comparing each of the element with the pivot. What I am comparing means, I am comparing lesser. That means I am comparing if each of the element is lesser than pivot. If it is lesser means I am incrementing the I. So as you know, right, for the left side elements lesser. So I am taking the reference as a I for the left side element, such that what I am doing is, I am incrementing I if it is lesser than the pivot. Okay. Once after that, I am also parallelly decrementing the j if each of the element from the right side, right direction, I mean this direction, okay, backward I can say, from this direction I am decrementing the j if each of the element is greater than pivot. As you know, as we have a rule, right, pivot right side element should be greater. So that for that I am taking the reference as j and I am decrementing it if it is satisfied that each element is greater than pivot. That's what I am doing in this algorithm. Again, I am just repeating. I am taking reference as I for the left side element such a way I am incrementing I if each of the element is less than the pivot element. Similarly, I am decrementing the j from this direction such a way if each of the element is, if and only how, when I am decrementing, if and only if each of the element is greater than pivot. Okay. So what I will do means, I will also write the pseudocode parallelly. Okay. So I have pivot, initialized pivot with lower index, which is the lowest one, and also I have taken I as the lowest one and j as the highest one. So I have initialized this. What I did, I have taken pivot as array of low, I equals to low and j equals to high. Okay, fine. So let's start the algorithm. So what I mentioned to you from, okay, first traverse from left to right for the I. Okay, once the loop stops means, if any of the element is not lesser than pivot means, then this I will stop and j will start the execution. Okay. Okay, don't confuse. I will tell you, but for now we'll start the algorithm like what for now I have explained the initialization. What is the purpose of initialization, right? So now I'll tell you how algorithm works. So I'll increment the I if and only if each of the element is less than the I. Okay. Now I is in the current position of 3, right? So now what I will do means, I'll increment the I. Okay, I'll increment the I if and only if I is less than or equal to. Okay, so what I said, one second, less than or equal to. So if if I is less than or equal to pivot, then increment it. You said less than, right? Again, why you are highlighting equal? You may get this question. I'll tell you this answer at the end of this session, but for now please bear me. Okay. Okay. So if I is less than or equals to 3, yes, I is less than or equals to 3, then increment the I. Okay, because anyways equal is getting satisfied, right? So increment the I. Okay, I have incremented it. If again, let's come back again. If 2 is, I is less than or equals to pivot, yes, 2 is less than pivot, increment the I. Okay, j anyways it is in the current position. Now increment the I. Now I is in the position of 1. Okay. Pivot is 3. I is in the position of 1. J is anyways at it's at highest position, because we are not, as of now, we are not dealing with J. You are first crossing the I. Okay. Fine. Okay, now let's write the pseudocode parallelly. So what I said to you, I was incrementing the I if and only if I is less than or equals to pivot. So that's what I have written the pseudocode. So after this initialization, what I am doing is, make sure I should not be at the high, make I less than or equals to high means make sure I should not cross at the end. Okay, it can cross the last position, but after that it should not cross, because there is no error, right? So that's the reason, less than or equals to high. And make sure each of the element, whatever you are comparing, make sure it should be less than or equals to pivot, then only increment it. Okay, understand, right? Okay, so just guess what will happen in the next slide. Like I may points to here, because 1 is less than or equals to 3, right? So 1 is less than or equals to 3. Yes, correct. Then what will happen? We will increment the I. Yes, we are incremented the I. And again J is as usual, it is at last position only. Now what will happen? 4 less than or equals to 3? No, not at all. So the loop, whatever the while loop earlier I have shown to you, right, that will stop execution. Okay. And now J will take care of it. Hey, you stop. Hey, hi. Now your duty is over. So I'll take care of it. So what it will do means, now J will start comparing it. Okay. So J will again compare with the pivot with greater. Okay. So is 5 is greater than 3. Yes. Then what we'll do? We'll decrement it, right? So I is in now fourth position, yes, 0, 1, 2, 3, third position, and J is now decremented is with J minus minus, like at which is at pointing to 6th element, right? Okay. Again, so see again, J will also stop the execution until unless the element is less than the pivot. It will decrement it. It will decrement it until unless the element, suppose until unless the element is less than 3. That means it will decrement. It will decrement it if the element is greater than pivot. It will decrement it, but the loop will get stops if the element is less than the pivot. Okay, fine. So now again 6 is greater than 3. Yes. Okay, again it will decrement it. Okay, yes, again it will decrement it. So what is the pseudocode for this? Make sure I should not cross the low. Like I can be at here, at a position where it is pointing to 3, but make sure it should not cross the uh, low, because there is no value in that. So that's the reason J greater than or equals to low, and area of J should not, make sure it should be greater than the pivot, then only decrement it. So as I said to you, this loop will stop if and only if this element is less than the pivot. Okay, fine. So this is the parallel pseudocode for J. Okay, fine. So if you observe here, again, as we currently J at this position, right? So if again, if is J is greater than pivot, yes, then obviously J will decrement it, and J is in the position of 4. Okay, so now I and J are in the same position. Fine. Okay, let's again see, is 4 is greater than 3? Yes, again J is, see J is continuously decrementing, yes, because the condition is getting satisfied. 5 is greater than 3 satisfied, 3 is greater than 3 satisfied, 7 is greater than 3 satisfied, and 4 is greater than 3 satisfied. Okay, So now I is in the position of 4 and j is in the position of 1. If you observe here, I crosses j. Yes, that means j crossed I. So not I crosses j. J is crossed the I. So definitely this is not a valid case. Okay. So that means I always should be less than say. If you see here, j is less than I. So this is not a correct position. Okay. So what we will do if at this point of time, what we will do means will not allow. So what I'll do, okay. Now I'll tell you the pseudo code for this. So if I is less than j only, we are swapping it. Okay. So again, you just now swapped it, right? Now you may have this question. See, if and only if I is less than j means you need to swap it. But you are swapping some other, where you are doing a swapping mechanism. You may have this question. Just slowly listen what I am saying. Okay. So you understand we have initialized the pivot I high, and I said to you, right, if I is less than high, I will increment the I position increment. If I is less than I, and make sure each of the elements should be less than pivot, then we are incrementing it. If coming to j, if j is greater than or equals to low, and if each of the element is greater than the pivot element, we are decrementing it. Fine, that's fine. Now let's say if I is less than j only, we need to swap array with whatever the positions that has I with j. Like let's say if j is in this position, and while execution stopped, and while of I execution stopped and j execution stopped, then we are swapping I and j. But here what we are doing means, I is not at all less than j. Okay. I is, see, let's say I'll take pen. See, I, j, if he in this direction, if it points means, then we can say it is less than j. But if you see here, j crossed I, that means here j is less than c. Again, j is, how you can say, see, just count the index. Where j is pointing 0, 1, 2, it is pointing to 2 index, right? And if you compare j ith value, it is pointing to 3 index. 2 is always less than 3. So this condition will not satisfy. So that what will happen means, this if will not execute, and in return this swap will execute and return j. Okay. Now I am gonna explaining you what exactly this meant to be here. Okay. Let me erase this. You understand, right, what I meant to say? So what I meant to say is, so I make sure I should not, j should not cross I. If that is the one, if that happens, then this is the wrong, this is not a valid case. And what we will do means, and if you observe here, this loop will end if and no if this loop will end if j crosses I. So that's the reason mm, before we writing this case, we are actually written this case as well. Okay. So fine. So if I is not, see, at this case I is not less than j, but now what we'll do means, we'll swap array of low of j and return j. Now I'll explain what exactly this swap of array of low of j and return j. Okay. So if you see here, let me erase this as well. Okay. So what it means, so swap 1 and 3 as per this case means, low means 3. Okay. And j means 1. Okay. So we are swapping 1 and 3. Low means yeah, that's what pivot, you can call it as a pivot. So we are swapping, low means nothing but pivot. Here as per my code, I have taken the pivot as 3, but don't confuse pivot. I am comparing with the pivot. Okay. So what I am doing is, I am swapping with the pivot element with j. Why I am doing? Just think of, see, pivot, if you choose, if you see, you are doing in an ascending order, right? Suppose when you are doing in an ascending order, definitely what we are doing is like we are saying, hey 1, we are calling to 3, hey please come here, I should be at that position. That means 1, that means what we are saying is, suppose if there is a case like J and I at this position, that means if J crosses I means you need to assume in such a way like J is the least element in this array, and J is saying, hey, I should be at the first position because I am the least element, and you should be at this position where before where I am at. Okay, right? Correct, right? See, if you think 1, 2, 3, if you take it as a mind, 1 is always at that position because 1 is the least element. So you should assume in such a way, if this position comes, that means J first and J next, means you should think in your mind that this is the least element, and definitely this element should be at which position? Lowest position only. So that's the reason we are swapping with our pivot element. Okay, then 1 will comes here and 3 will comes here. Not only that, if you, this is the for this is the purpose. Swap array of law of J means we are thinking, okay, J here is the least element of that array, so please we'll swap with the pivot element. Why we are swapping with the pivot element? Because that is the least element, and the pivot, we have chosen the first element as our pivot reference. Since this element, which is the least element, we have assumed that should be at the first position because we are doing in the ascending order. So that's the reason we have written this statement. And again, now return J. Return J means what we are returning? We are, okay, once it is swapped. So once it is swapped, what is the result? 1 will come here, 1, 2, 3, 4, 7, 6, 5, right? So now what is the pointing of return J? So return J means what is the pointer? 0, 1, 2. So it will point to the second, that is 3. So what it meant to say is, so what it points means, see, if you observe here, return J means it was saying, hey, anyways, this was get swapped. Now if you observe, what is the jth element? Pivot element, right? So we are saying return J, we are saying, hey, this is the pivot element, and we are also ensuring like this is the pivot element and the left side are already sorted. Make sure concentrate on the right side. Oh, no, again, sorry for getting confused. So what I am trying to say is return J. I have mentioned return J. Why we are doing return J? Because I am saying like at this point of time, return J, at this moment, the what we are returning J, we are returning at the index 0, 1, 2, second index we are returning. That means I am saying like, we'll go to the next slide. So left side elements are 1, 2. Okay, return J means what we are, means we are conquering it, we are dividing it, we are dividing to subarray parts. Okay, pivot right side element. So what we are returning is like, hey, this is the index I am returning to you. Make sure the left side you need to get sorted and the right side you need to get it sorted. I don't know if it is sorted or not, but this index I have given to you, and I am pretty sure that the left side of this index, that is which is pivot, are smaller and the right side are greater. Okay, but I am not sure still they are in the sorted order or not. So what you do means, I'll partition it, I'll divide into parts, conquer it, you take care of it. That is the purpose of returning the J. So returning the J means we are saying divide into parts, left side parts and right side parts, and again apply the same algorithm that we applied here. Okay, so that's what this code is meant to here. So int pivot index equals to partition. Partition is the one which we have seen earlier, right? So that is the one we are applying. And once, see, here in this function only, right, we are returning the j value. So we are returning the j value, and we are saying now now recursively apply the same sorting algorithm for the left side and right side elements. So for array of low comma pivot index minus 1, that means left side elements and right side elements. Okay. So, if you observe earlier, we have 1, 2 for the left side, right, which is already sorted. Okay, so we can ignore it. Let's concentrate on the right side elements. But if you observe right side elements, if you observe earlier pivot value is 3. Right now I have changed it to pivot 4. Why? Because I am applying the same algorithm again with recursively. So what we'll do, pivot, as I said to you, I am taking the reference as a lowest element for the pivot. I will be taking 4 as a reference as a pivot element. And as usual, I is always first in points to lowest index value, and j is pointing to highest index value. Okay, fine. So I is, let's start the same procedure what we have discussed earlier. So I is less than or equals to pivot. So that's the team. I also, as I said to you, I am writing the parallel. I am writing the pseudocode parallelly. Make sure you also write from your side and tabulate this what I am saying, so that you will be get memorized in your brain. Okay. Same process. I is less than or equals to 7. Sorry, 4 is less than or equals to 4. Pivot, we are comparing the less with the pivot, right? Yes. Okay, increment the I. Okay. Uh, if you observe here, sorry, I am in this fast approach. Let me go back. Okay, can't go back, fine. So, if you observe here, 7, okay, I have incremented I. Compare. 7 is less than 4. No, no, right? So it will stop the execution. It will stop the execution and J will not take care of it. Is 5 is greater than 4? Yes. J started decrementing it. Okay. Is 6 is greater than 4? Yes. J started decrementing it. Now I and J are in the same position. 7 is greater than 4? Yes. J again started decrementing it, which is not a valid case, as I said to you. So what will happen? We are swapping with the pivot with the one the j points in anyways it is in the okay, let's swap it, but anyways those are in the same position, right? So what will now we'll do means we are returning the j. So what is the what I meant to say returning j means, we are returning the index j, that means 0th index we are returning. So that means hey, the one which I have returned to you was sorted. Please take care of left side and right side. Anyways, for this left side is not there. So this function will execute. That means 7, 6, 5 are the elements. Now for the next subarray will come into picture. That's the reason divide and conquer. Divide means we are dividing, taking as a we are dividing the subarrays once with the pivot index, that is this one j. Okay, so what we are saying means if there is any lowest value we are swapping with the pivot, and once in such a way that the jth position will comes with the pivot. Pivot means j position uh, will at the end of the recursion j will point to the pivot, and we are returning the jth index such a way like this pivot element left side is smaller and the right side is greater, but I am not sure if it is sorted or not. So you please take it, you conquer it, make sure left side you apply the recursion and right side you apply the recursion and and sort it. That's the reason divide on the basis of jth index. Again jth index means pivot index, I can say, right? I can say pivot index. So divide on the basis of pivot index and make sure sort it left side and right side accordingly. Okay, fine. So now the array will be, new array will be pivot, this is pivot. Anyway, left side is not there, right side elements is 7, 6, 5. And again the same procedure starts. Like pivot is 7, so I will be points to 7, j will be points to 5, and pivot is 7. I less than or equals to pivot, yes, increment the I. Okay, okay, fine. Now again I is less than or equals to pivot, 6 is less than or equals to pivot, yes, increment the I. Okay, fine. Now 5 is I is okay, 5 is less than or equals to pivot. Oh, but 5 is less than 5 is less than pivot, but if you observe here, there is no of incrementing, right? So we should I mean there is no array to increment it, so this loop will not execute. Now J will take care of handling this. Like, is J, I mean while loop stops here, but if you observe here, I is reached to the end of the array, right? So loop execution stops here and J will start taking care of it. So J is great, each of the element, whatever points to J, is it greater than pivot or not, we are checking. No, see, is 5 is greater than 7? No. Okay, is 5 is not at all greater than 7, the loop will stop. I mean the loop will stops in the sense 5 is not at all greater than 7, j loop execution stops. Okay, then if you memorize, if I is less than j, we are swapping it. If not, we are swapping with the jth index with the pivot element, if you remember. So again I said to you, why we are swapping, because we are saying, hey, whatever now I'm in the position, whatever now I am in position, uh, that is the most least element, and that's the reason I am swapping with the pivot, because pivot is acting as the lowest index here. Okay, so that's the reason I'm swapping. That's the reason 5 will comes here, 7 will comes here. This way we are getting the sorted order, that is 5, 6, 7. Okay, so earlier if you see, for the first recursion I got the sorted order 1, 2 and 3 as a pivot element, and I have concentrated on the right side elements, that is 4, 7, 6, 5. For the 4, 7, 6, 5, anyways I didn't got any swapped element, but if you just common sense apply, because why 4, 7, 6, 5 you didn't got any swapped elements, like you just got the same array but just partition happened, because 4, 7, 6, 5 anyways the right side elements are anyways greater, although it's not in the sorted order, but it's greater, right? 4 is greater than 7, 4 is greater than, sorry, 4 is less than 7, 4 is less than 6, the right side elements are anyways greater. So what we have done is we have conquered it. Okay, these are not anyway swapped, but we can conquer it. What we can do means we can partition the pivot element index, and if left side elements are there, you can take it that as a conquer and apply the recursive algorithm. Anyways, for the left, for 4, 7, 6, 5, once we return the index the 4, we got right side elements to be get sorted, that is conquered it. We applied the conquer algorithm for the 5, 7, 6, 5. And if you see for the 7, 6, 5, we try to swap with the lowest, anyways j pointing to the lowest one, that is 5. We try to swap with the 5 with the pivot element which sits at the lowest index. So that's how it got swapped. Okay, so this is the quicksort algorithm. Please let me know if you have any queries. Put me, if you find this video useful, please comment me in the, please comment it, and if you find any, if you have any queries also, please put in the comment section. I'll reply to your comments. And yeah, please share this YouTube channel, please subscribe it, and also follow my Instagram Java DSA workbook. You'll find awesome useful notes for you. It's related to not only sorting, I have put in graphs related notes. Still that was in the live only, so you can follow it that as well. So you'll find every day I'll put a 2 to 3 lines of notes, means you don't not say any paragraph. Okay, just you'll see 2 to 3 lines of notes that will help you for your learning, or taking you the forward for the Java DSA. Uh, that will help you to crack any interviews or any exams. Okay. Yeah. Thank you. Thank you. Bye.